Today is going to be our Intro to Proofs Day. So what is a proof? A proof is just a formal way of writing up a problem. Like you show every single step and then you write out all your words, like write out each step in words. So anybody who reads the problem can, even if they don't know much about math, they can kind of follow what you did or say, oh, that kind of makes sense. So the important things here, you need to write out every single step, like every single step. Don't do anything in your head. You need to use words. It can be real basic words. It doesn't have to be sentences, but use some kind of word to describe what you're doing and then also use your correct math notation. A lot of times problems will be prove that this something equals something else, and so don't ever like add or subtract across this equal sign. You're not dividing, it's not an equation. Think of it as this is my problem and this is my answer. So prove that X simplifies to Y. Maybe that's a better way to like rephrase the problem in your head. So last week we talked about how to simplify, and so these are some of your hints that'll help you during proof writing. We talked about simplifying, and so one way to simplify is to distribute and combine like terms, or if you have fractions, it helps to factor and cancel. So all of these, I know you may not believe me, but all of these we're trying to just make it simpler, so we're going to want to use these tricks here. Another hint that we're going to use today is to convert everything to sines and cosines. In the past, we've just been dealing with sines and cosines, but now we're going to throw in tangents and cotangents and all those kind of things. So here are some of your Here are some of your identities that'll help you convert. These are new identities you're going to need to have memorized by the end of the test. So tangent can be written as sine over cosine. Cotangent can be written as cosine theta over sine theta. These are all your reciprocal identities, which we used at one point when we did SOHCAHTOA, TOA, and we flipped our fractions to find all the different pieces. And then here's your Pythagorean identity. You only have to have the first one memorized, but you can know all of them if you want to. Okay, so let's actually do an example now of a proof. So our first one, example 1, prove that tan theta parentheses cosine theta minus cosecant theta parentheses equals sine theta minus secant theta. All right, so what I meant by don't work across the equal sign, we're not going to add this secant over here. We're not going to divide by tangent. It may help you to reword this. Instead of having an equal sign, think of it as the physical words simplifies to. So we're going to start here, and then I'm going on and telling you what we should end up with. Okay, so if we follow along with what we did last time, the past couple classes, we've been trying to simplify these problems, and so remember, to simplify, you can distribute and combine like terms, you can factor and cancel, but in this case we don't have a fraction, so we're not going to factor. This doesn't have to be your first step, but for me, it helps if I distribute and combine like terms. So for proofs, make sure you write some kind of words, and then I'm going to distribute, so tan theta times cosine theta is tan theta cosine theta, and tan theta times negative cosecant theta is negative tan theta cosecant theta. The point of distributing is so that hopefully you have like terms that you can combine, but in this case, these aren't like terms. This one's got a cosine and this one's got a cosecant, so it's not very helpful. But we have new tricks we can use today. You can convert everything to sines and cosines. Notice right now I have a tangent, a cosine, a cosecant, a sine, and a secant. That's 5 different trig identities or trig functions. Let's just convert it down to sines and cosines so we only have to work with 2 things. It's easier to simplify 2 things than 5. So use these identities here, and let's convert everything to sines and cosines. So convert to sines and cosines. All right, tan theta is the same thing as sine theta over cosine theta. Cosine theta is already written as a sine or cosine. If you want to write it as a fraction, you can put it over 1. Tan theta is sine theta over cosine theta, and then cosecant theta is 1 over sine theta. All right, so Now that we have everything written in terms of sine and cosine, let's go back to our simplifying hints and see if there's anything that's helpful here. We've already distributed and combined like terms. We can't really do that, but we can factor and cancel here, or we don't have to factor because these are already multiplied together, so I don't really have to break anything apart. It's already telling you multiplied these two, multiplied these two. But I can look at each individual fraction, so I can look at this fraction right here and cancel things out because it's already factored, it's already in its multiplied pieces. So I can cancel my cosine on top and bottom. So that'll be our third step. I'm going to cancel so that way I can simplify more. And I'm left with just a sine theta. And then for my second piece, I can cancel here. I have a sine on the top and bottom. It's got to be one from the top and one from the bottom, and they have to be multiplied together, not added or subtracted. So this time I have a cosine that stays in the denominator. Leave it in the denominator. So I have sine theta minus 1 over cosine theta. Now would be a good time to double check and look back at your original problem to see what your answer is supposed to be. Right now we're super close. We have a sine theta, but our second piece isn't the same. Luckily, and eventually you'll have all this memorized, this is secant theta. It's your reciprocal identity. 1 over cosine is secant. So my last step here is reciprocal identity, or you can say convert, or you can say convert back. I don't care what words you use, as long as you're not saying something like subtract when we clearly did not subtract. But I can rewrite this as secant theta, and now I had started here, ended here, which is what I was supposed to end with, so I'm finished. Those two little lines mean I'm finished. You can also use a filled in black box, QED, which I think is some kind of Latin phrase, or you can just stop if you want to just stop. So started here, distributed, converted to sines and cosines, so then I could actually simplify some more by canceling my fractions, and then I converted back and got my final answer. Okay. Let's do 2 more of these. All right, so example 2, should have had this written out already. It doesn't have to necessarily say prove. They can also say show. So let's show that parentheses sine theta plus cosine theta parentheses secant theta plus cosecant theta equals or simplifies, I spelled that wrong, you know how to spell it, to tan theta plus 2 plus cotan theta. Okay. All right, so a couple options of how you can start. To me, I think I like to always start by simplifying or converting to sines and cosines. I guess that gives you 2 options, but I'm going to simplify. Okay, so one way to simplify is to distribute everything and combine like terms. So let's distribute everything. So step number 1, distribute. All right, so I can distribute sine times secant is sine theta secant theta, and sine times cosecant is sine theta cosecant theta. Distribute your cosine, so cosine times secant is cosine theta secant theta. Distribute your cosine, cosine times cosecant is cosine theta cosecant theta. Okay, now that I have that, combine like terms, but as you can see, there aren't any like terms. Nothing in there, none of these 1, 2, 3, 4 pieces have the same 2 trig functions in them. So I need to use another hint, another trick. My only other trick is to convert everything to sines and cosines. Because right now we have a sine, a secant, a cosecant, a cosine, and we're supposed to end up with tangent and cotangent. So if we convert everything to sines and cosines, maybe something will simplify. And if not, maybe we'll recognize one of these identities here, because all of these identities are written in terms of sine and cosine. So let's convert to sines and cosines. All right, so sine is already written as sine. Yay. I can write it over 1 if I want to, or if you want to see it as a fraction. Secant is 1 over cosine. Sine is already written as a sine or cosine. I can write it over 1. Cosecant is 1 over sine. Cosine is already written as a sine or cosine. Secant is 1 over cosine. I can write this as cosine over 1. And cosecant theta is 1 over sine theta. Okay. Now that we've done this, nothing immediately jumps out at me as an identity, but I can use my simplifying hints. I can cancel things now because I have fractions. I have 4 fractions. As long as you look at each fraction individually, you can cancel. So like in this first fraction, nothing cancels out. The 1s, but that doesn't help. But in this second fraction, I have a sign on top and a sign on bottom. So I can cancel those 2 out, and I'm left with just the 1s. Or remember, when everything cancels out, you use a 1 as a placeholder. So nothing canceled in the first fraction. Everything canceled in the second one to leave me as a 1 as a placeholder. In my third fraction, same thing. My cosines cancel, 1 on top, 1 on bottom. So if everything cancels, use a 1 as a placeholder. And then for your last one, nothing cancels out. So I'm going to leave it as cosine theta over sine theta. So that step was to cancel. Hopefully you're trying to think through the problem ahead before I tell you the next step. So for this one, look at what we're trying to get to. I would hope you also notice that 1 plus 1. 1 plus 1 is 2. So you can either say this is adding, or you can say combine like terms because they're both numbers. But I can add these 2 together and get a 2. I still have that first fraction, my sine theta over cosine theta, and I still have that last fraction, the cosine theta over sine theta. So, oh, you can't see what I just wrote. There we go. So I have my 2, which is my key, but my first and last fraction, those aren't tan and cotan. Luckily, we know how to convert. Oh, there you go. Sine over cosine is tangent, cosine over sine is cotangent. So I can use my tangent identities here, or you can say convert back, or you can just say convert. And so this first fraction is tan theta, and this last fraction is cotan theta. And now I've gotten where I'm supposed to. So full problem, distribute, convert, cancel, combine like terms, and use your tangent identity. You don't have to do it in that order. You can sometimes switch, like you could have converted these to tangents and cotangents before you added together to get the 2. Just make sure that you show every single step. Don't do anything in your head, and don't combine steps. All right, let's do one last one.